Hello all. Today we are solving LeetCode problem number 3454, separate squares 2. So yesterday we solved separate square 1 where the problem is medium, but this is very hard. The problem statement, it is very similar to the yesterday's problem, but there is a small difference uh, which makes the problem very hard basically. So let us jump into the problem. So we are given a 2D integer array squares where squares of I is equal to list of xi, yi and li, where xi and yi are the coordinates of the bottom left point of the square and li is the side length. So what exactly this mean? Consider a grid where we can have the coordinates that's 1 and 1, which is the left bottom point of the square, and li be the side. So side will be li, which forms a square, and the coordinates from the left bottom point will be the xi, yi. So now we need to return the minimum y coordinate value, which makes the total area above the square equal to total area below the square. So return this as a float value up to 5 decimal places. So what exactly this mean? So for example, if we have only one square um, in the coordinate in the grid, we have to find the minimum y value, which will make the area above this line equal to the area below this particular line, right? And this should be up to 5 decimal places. So this is what we have to return. There can be two squares also, and many squares, as much as of squares we can have it here, right? So one thing to note, so this is what makes this problem so hard compared to the yesterday's problem. So if squares overlapping area counted by overlapping area counted only once. So in the previous problem we can count the overlapping area, but here it counted only once. So which means if there is some squares which overlaps, right? So here we have to count only once, right? And we have to count these. So which means union of the area. That is what we have to find here, right? So how are we solving this problem? So before solving this problem, we have to understand, let me explain about why exactly, what is y and why are we finding y. So let us imagine, let me erase this off quickly. So we have a grid, right? And we have a square, and let this be y. So here we have to understand the formula, like what exactly is y and how do we find y, right? So to find y, what are the things we needed, right? We need a total area, which is the area of complete rectangle we need, right? And so based on that, we will be getting the target area, which is total area by 2. So using this only we can find, right? So uh, which means the target area is equal to length cross breadth, or can be height cross width. So in this case we are taking height cross width because of the grid which we are using for this particular problem, right? So this means we can have area is equal to h cross width, and now height is equal to area by width, right? So this area, what exactly is this area? this area can be uh, because this, since it is cutting that particular uh, shape or square, this area will be the area of the target area minus the cutting area, right? So area minus the cutting area. So we can have it as h is equal to target area minus area by width, right? And now what is this y? Because if you see here, we have the y coordinate available here, and we have the height, right? This will be decided by the y coordinates value, so we need to find this particular height, right? So how do we find it? Like, this will be the uh, height minus y is equal to target minus area and width. By this height I mean the coordinates value, which is 0, 1, 2, the coordinates available in this particular grid, right? So that determines the y. So what exactly we need is this y. So by this we can say that y is equal to, bringing this right this side, this becomes and removing this negative value, this becomes height minus, this will be area minus target by, or let us have this outside only, yeah, that is good. So width, this will be target minus area width. So this is the formula. So remember this formula, we will be using this to substitute to find the value of y. So now let me explain this example, or I can explain another example. We will be, how are we solving here is, we will be using an advanced concept called line sweeping. So let us assume this be one square and this be one more square. So by line sweeping we can decide, or we can find the band length. So by band length, what I'm saying is, we can find this y coordinate length here. So we will have several lengths, so which is, one is this and one is this and one is this, right? So we have x intervals also, which is, let me use one other color. So this is an x interval, right? And this is an x interval, and this one and this one is one more x interval, and this one and this one, right? So we have many in a particular band. For example, this be band 1, we have one x interval, right? And in band 2 we have, sorry, this is also one x interval. So we have 1, 2, 3, 3 we have here, we have 1 here, and 1, 2, 3 again. In band 3 we have 3, and this will be band 4, where we have this I think, yeah, this is only 1. So right, so with this we can what we can do is, we have to there is overlapping happening here, right? Because of this area, the overlapping happens between this square and this square. So because of that, we have to add some intervals and subtract some intervals for the area calculation purpose. So because of that, we have to assume or I mean, we have to store this interval using add or subtract. To indicate this, we can have +1 for addition and -1 for subtraction, right? So so with all these, uh, we can say that how do we save all these? We have to save these intervals and this add as a list in a default defaulted data structures, and the key for it will be this band. So which is, oops, this band, which is the y value, right? So this is what we are doing first, and then we are sorting it, and then iterate. Right, calculate total area. I mean, by using these values and the y value, you can and also the length value, you can calculate the area, right? And after that, you have to store this, because you have to cache each of all these areas to find the next step. So catch them, also accumulate them. This is to find total area, right? And now when you find total area, you get target area, right? Now here also you have to find the width by using the x intervals. So you have to define a function there, and you have to find the x intervals or the width using that. And now you have cached value, right? So and you have target. So now you iterate through this cast value, right? And accumulate and check if the area, which is the accumulated area, is greater than or equal to target. Then there you go, you got the point where you can find the y value, because this is the place where the area is greater than the accumulated area is greater than the target, greater than or equal to target area. You will be getting the place where you will get the point where the cut point lies, right? So then substitute the y formula, and you have two areas available, which is target and the accumulated area. Subtract them and substitute them in that, and you have height also there available, because you for respective area you will have the height stored in the cast, right? You have height, and you have width also accumulated with this cast area. So let me write down the formula. So y formula is equal to height minus area minus target by width. So you substitute this, you get the y value, and you return it. So that is it. So let me run down the first example for the clear understanding, right? The second example probably. So we need some specific values here, right? So let me expand this a little bit and write down, we need points, which is the default dict, right? And we need for cache, right? And we need width, this should be 0 first, and height, area 0 0, and we need the current points to track the currently active intervals, right? And and what else do we need? We need a target, which is what we are going to find first, right? So now we have these two as the points, right? So how do we find the value here, the point value here? As I said, we need to find we need to find add, subtract along with the x value and x plus l value, right? So based on that, if you take this point, this square value, you have to add or subtract, right? Let me write down here. So you have to add or subtract, which is 1, or yeah, 1, and you have x value as 0, and x plus l will be 2, right? And you have to subtract, which is -1 and 0 2. And similarly for the next square, this will be 1, and x is 1, and x plus 1 will be 2, right? And again -1 1 and 2, right? So how do we determine the y value for this, right? Because this square starts at 0 and ends at 2, so for negative this will be 2 for negative, and for positive this will be 0, right? So this maps to 0, and this maps to 2, right? And for 1 starts at 1 and ends at 2, right? So negative will be 2 and this will be 1, right? So based on that, we have to write it down. So for 0 as key value, we have 1 0 2, and for 1 as the key value, we have 1 1 2, right? And for 2 as the key, we have the value as -1 0 2 and -1 1 2, right? uh, Let me erase this down because it's confusing here, right? So yeah, right. So now we can start. We have to iterate this, right? So first, when we take this for the first iteration, let me change the color of the pen, and let me take this for the first iteration, and then we need to find the height, right? So this is you have the width as 0 and 2, which is the width will become uh, oops, yeah. So the width will becomes 2 here because of 0 and 2, and the height, it will be, you have +1 here, right? So, and what else, the height should be uh, 1, because we start from here and we stop here, right? So h plus the h of I will be 0 because of the key value is 0 here, and h plus 1 will be 1. So subtract of these, we have to subtract this, which results in 1, right? And now area will be 2, and the current points will be 0 comma 2. And we have to cache this. So I said that for caching this, what are all the values we are using here are uh, the height, then the breadth, and which is 2, and the area, right? So this is the first iteration, and then we jump here. In the next iteration we get this value, right? And y will be 1, and because of that h of I will be 1, and h of I plus 1 will be 2. So 2 minus 1 will be 1. So we erase this, and this, oh sorry, this should be 1 again. And now the width will be uh, again this is 1 and 2, right? So now the width again will be it will be 2 again, and now the area will be again 2, which is we have to increment here, which results in 4. And we have to cache this again, so this will be 1, 2 and 4. Oops, here this height should be, we have to note down the height of h plus 1 here. I'm sorry about that. We have to note down this height as not h of I, this should be h of I plus 1. So because of that, this will be 2, and this will be 2, and this will be 4. So this is what we are noting it down here. And the current points will, and the current point will be this should be 1 and 2, right? And now we are having 4. And now in the next iteration, if you see here, we have 2 here, but there is h of I as 2, and there is no h of I plus 1, right? So because of that, we stop the iteration at this point. There is no more iteration. So because of that, the total area will be 4, and target will be 2. So now for finding y, we can substitute the value. We have h as 1, and if you see here, target as is 2, and the area is also 2, and this width is 2. So because of that, y is equal to 1 minus 0, and y is equal to 1, right? So what exactly is the answer we are returning? I mean, in the example it is given. So with all this observation, let us go ahead and code this up. So the time complexity for this will be big O of n log n. So because we are using sorting functions to sort the default dict and things, right? So because of that, this will be big O of n log n, and the time space complexity will be big O of n because of using excess memory, because we are using default list and then list there, right? So because of that, this will be big O of n. And then yeah, so first if I am defining the points, default dict, which will have list, and we have discussed that this will have the add or subtract and the x and the x plus l value, right? So, and I will define target also will be 0, and now we have to store the values in the points, right? So for x, y and l in squares, points of y, because we have to append that we are having the key as the y value, right? So 0, 1 and 2. So because of that, dot y append. For add, this will be positive 1. Oops. One and x plus l, right? And points of y plus l, this will be the next key value, and append here this should be -1 because we are using this to find subtract and find the overlapping width, right? So x and x plus l. So now we have to define the current points. Store the active intervals and area to calculate the accumulated area, and then we are cache to store the width, height, and the areas as a set or as a list respectively, so that we can iterate through that and we can finally return it based on using that particular height calculation function, right? So now we have to have heights, right? So here we are having only possible three heights, which is 0, the y coordinate value, which is 0, 1, and 2, and because of that I think we can sort the value and then store it. Heights is equal to sorted, then we store it in the list. And we how do we store it? Like, we are fetching it from the points because we are having the keys as y coordinates value, right? So because of that, points keys, right? Yeah, and we iterate through the height. So range len of heights, right? And this should be -1 because we are iterating till the last from indexing will be 0 to that point, right? So we have only 3 heights, so because of that it should be -1. And then we have to calculate width, because this we are using this to find the area, the accumulated area, and update the cache, which we are doing here. So because of that we need the width, and for width we need to calculate based on the overlapping intervals. So because of that I'm going to define a function here. So update width function, where we are passing heights of I, right? So based on the y coordinate value, we will be getting the y coordinate band, and in that particular band we have the intervals, right? Overlapping intervals there. So based on that we will be calculating that, which I will be writing the functions after finishing this piece of code. So now area, so area are equal to, this is the accumulated area, right? So because of that we have to calculate the interval, the height interval, so which is height of I plus 1 minus height of I subtracted. You will get the difference height, which you will multiply with the width to find the area, right? Because that using the difference of two band, you will be getting that rectangular areas, uh, rectangle's height, right? So using that you will find the area, right? So because of that it should be heights of I plus 1 minus heights of I, right? And this should be multiplied with the width which we are finding by help of the function, right? So now we have to cache this. So here we have to update with the height of I plus 1, and along with we have to add width and then area, right? So now we will be finding anyhow we will be finding the target actually. And now we have to find the target, right? So the calculated area, total area divided by 2 will be the target. So is equal to by 2. And now you have to iterate through the cache and apply the function if the area is greater than or equal to the target, right? So So we have three values in the cache. So we have height, width, and area, right? So for I in cache, then if I of 2, index position 2, we have the area, right? So it is greater than or equal to target, then we return by calculating the formula, right? So based on that, this will be height minus, right? So which is I of 0 minus, now you have area minus target, so which is I of 2 minus target, and then this will be divided by the width, so I of 1, right? And now this is how we find, but now we have to define the update with function, right? So we will define this here, so where we pass in the height of I, which is the y coordinate value, and then now we have to start by adding the x and L value, which is x plus 1 value from points, by fetching that by the y key value, y as the key value, and add them into the current points list, because we need to get the current interval available in the particular band, right? So for because of that, so for we have to check if that is add, right? The value which is -1 or +1. So because of that, so for add and x and L in points of y, right? If add equal to 1, then we need to sort it. So because of that, I'm using insert function. Insert left current points, right? Current points, and this should have x and L value, right? Oops. And else, which means you will have add as -1. So in that case you have to remove it, right? So remove, this will be x comma L, right? And yeah, so now you have gone done with the current points which have the available active intervals. So now you have to find the overlapping, based on the find the overlapping intervals, and then subtract it, then find the total width, right? So how do we do that? So first we need to store the width, a variable to store, and then initialize the pointer to left, pointer left as 0, and now you just iterate through the current points, right? So for we can have the interval, we have two, that is x and L, that will be the intervals which is left and right, right? So because of that, L and R in current points, if L greater than or equal to left, right? So in this case this will not overlap, right? Because if the leftmost point of the interval is greater than the left, which is the pointer, then there will not be no overlapping. So because of that, so width we can add it, right minus left, so minus left, can add it right away, and then update the left pointer to the right to check the next interval if it is overlapping or not. So left is equal to right, right? And then LF here this condition we are I'm not writing the separate condition for partially overlapping and overlapping. In fact, this will satisfy the both conditions also. So left, if it is greater than left, right? So the rightmost interval is greater than left, then we can say that this overlaps. So because of that, width equal to r minus left, we subtract this and then we add it, and again we update left is equal to r, and then finally we return width. So this is how we get the width. So I think it is good enough. Let us go ahead and submit it. I found the issue here. This is because of I missed this bracket here. Because of that, this is being considered as just a single parameter. So I the same mistake was found here too. So now this is working. So let me go ahead and test it, and then let me go ahead and submit this. And as you can see, this is very efficient solution. Thank you.